Morning all of you. Today we are going to study very important article in the third year BSc second year BSc, that is mathematical paper, mathematical physics, and in that paper this is very important article we are going to study today here, that is solution of a first order differential equation. Solution of first order differential equation. Generally, we have to study in the last period, that is order and degree of differential equation. The highest derivative we have to consider for finding the order and degree of the differential equation. Here we have to consider a general linear differential equation for nth order, that is f0 of x into dny upon dx raised to n plus f1 of x into dn minus 1 y dn minus 1 into y divided by dx raised to n minus 1 plus fn minus 1 of x into dy by dx plus fn of x is equals to say f of x. This is the general differential equation for nth order, that is f0 of x dn d raised to ny upon dx raised to n plus f1 of x into d raised to n minus 1 dx raised to n minus 1. Also next term is f2 of x dn raised to d raised to n minus 2 upon x raised to n minus 2. Then third term, fourth term. Up to that we have to write nth term. The second last term is n minus 1 of x into dy by dx. And the last one is fn of x is equals to say f of x. This is equation number say 1, and put n is equals to say 1 in this equation. What we have to get that? We have to get the equation is f0 of x into n ची power किती आहे 1, that is dy by dx plus here f1 of x into n ची power काय होईल 1 minus 1, that is dy raised to 0 upon dx raised to 0, and something raised to 0 means what? 1, and it gets that is dn minus 1 minus 1 it is 0, and it gets say 1, and that is also we have to say that f0 of x into dy by dx. Again we have to say that f1 of x, and this gets what factor what we have? This factor is 1, that is dot. We have to write that is plus 1, and into again we have to say that f1 of x into dy by dx plus f0 of x is equals to say f of x. Means finally we have to write that this is what 1 general equation is. We have to write that say f0 of x into dy by dx plus f1 of x is equals to f of x. This is general equation. We have to write that this factor gets what we have 1, and then we have to generally we have f0 of x dy by dx f1 of x f of x. This is the equation we have to write, or this can be written as here we have to consider f0, divide both all the terms by f0, and it gets that dy by dx, and f1 of x upon f0 of x is considered as say p of x, and f of x divided by f0 of x is considered as q of x. This is equation number say 2. This is very important. dy by dx plus p of x into say dy by dx into, we have to consider here, this is say f1 of x into say y is, we have to write here fn of x into y. This is say we have to y here also y f1 of x into say y, and finally it gets that is general equation is this one. This is say considered as a y, and into q of x is equals to say 0. Understand? General equation for the general differential equation is f0 of x is equal f0 of x dn y by dx raised to n plus f1 of x into d raised to n minus 1 y into dx raised to n minus 1 plus dot 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 fn minus 1 into x dy by dx. And again we have to say that fn means what? f0 of x into y, and direct finally we have to write that this is what? f0 of x into dy by dx plus f1 of x into dy by dy. This is last term is its only we have to repeat it, and that's why we have to write that this is the equation of the type f0 of x into dy by dx, f1 of x into y, f of x, or this can be written as when we have to divide this equation by f0 of x, at that time dy by dx is as it is. f1 of x divided by f0 of x is considered as a p of x, and f of x divided by f0 of x is considered as a q of x. So this is the we have to consider, that is first order differential equation dy by dx. What is the order of this equation? That is dy by dx is the first order differential equation. Dy by dx plus p of x into y is equals to say q of x. This is the first order linear differential equation we have to consider, and the solution of this equation we have to interest to find the solution of this equation. The first of all we have to solve this equation. To how to solve the equation 2, let us consider a simple equation when q of x is equals to 0. To solve equation, consider q of x is equals to say 0. When q of x is equals to 0, this is called as homogeneous equation. dy by dx plus p of x into y is equals to 0. This is the equation we have to consider as the resulting equation is a homogeneous one. Therefore, homogeneous one. Resulting equation is a homogeneous equation, and then we have to separate the variable. What we have to get that? That is dy by dx is equals to p of x into say y, a plus minus, and finally we have to write that 1 by y into dy by dx is equals to say minus p of x. Separate the variable and integrating this equation, what you have to get that? Therefore 1 upon y into dy is equals to minus p of x into say dx. Integrating above equation, we have to get that integration of 1 upon y into dy is equals to minus integration of p of x into dx plus say constant of integration is say c, and this is say equation is we have to consider say equation number say third. This is equation third, that is 1 upon y into dy by dx is equals to minus p of x is the equation number say 3. And now take the integration of this equation. What is the integration of 1 upon x into dx? That is log of x, that is ln of y. Ln of y is equals to integration of minus p of x into dx plus say c, where c is a constant of integration. Arbitrary constant. C is called as what? Arbitrary constant of the integration. And now we have to write this equation taking exponential both sides. Therefore, y is equals to exponential of, we have to write that exponential is considered as say exp, exponential of minus p of x into say dx, p of x into say dx into e raised to c, where e raised to c is equal to say capital A. E raised to c is exponential raised to c. This is say equation number say 4. This is equation number say 4. Now we have to consider here, therefore y is equals to, this is considered as say a into exponential of minus of p of x into dx. Y is equals to a into exponential of minus integration of px into dx. Equation number say 5. Equation 5. After that we have to consider, to simplify the notation, we have to put integration of I is equals to integration of p of x into say dx. Put I is equals to say integration of p of x into dx. Equation number say 6. Therefore, equation 5 becomes y बराबर, that is a into, this is considered as say e, and e raised to what we have to say that I, and therefore we have to write that a is equals to, this can be written as y upon e raised to I, and finally we have to write that is a is equals to y into e raised to minus I, e raised to minus I. This is what we have to say, that minus sign is there, minus sign is there. Here we have e raised to minus I, and because finally it is say plus. This is, we have exponential of, here minus sign is there, that's why this is minus. And this is equation number say, we have to consider, that is differentiating this equation with respect to x. X. Differentiating this equation with respect to say x, we have to get that, therefore d by dx y raised to I, and that is equals to derivative of first is dy by dx, that is y dash, into e raised to I plus second function, for derivative of first, second function as it is, plus first function as it is, derivative of second, what is derivative of e raised to x? E raised to x derivative e raised to x into derivative of x is what we have to say, that di by dx. Di by dx. Right? This is the differentiation of this equation we have to consider. But di by dx we have to consider here Mm. P of x, no. This can be written as, yeah. This differentiation of this is what we have to say, that from equation 6, di by dx is equals to, we have to consider, say, p of x, and then we have to get that finally d by dx y into e raised to I is equals to y dash e raised to I plus y into e raised to I into, say, p, and take e raised to I is the common, therefore y dash plus yp into e raised to I. This is what we have to say, that d by dx y into e raised to I, and this is equation number we have to consider here, that is equation number 7. This is equation number 7. After this equation 7, we have to write that is returning now equation 2. Let us simplify. Returning equation 2, let us simplify here, that is how it can be, that is we have to write that equation 2 here. Let us multiply it by e raised to I. E raised to I. It gives that e raised to I into y dash plus p into y into e raised to I is equals to q into e raised to I. Now, what is the common factor here? E raised to I, and it gives that y dash plus p into y e raised to I is equals to q into e raised to I. This is the equation we have to get here, and this is equation number, say, that is 8. Equation 8. After that, from equation 7, we have to write that वरून आपल्याला काय लिहिता येईल. This is what this factor is a d by dx y e raised to I, and that is equals to q into e raised to I. Am I right? This is equation number, say, 9. Equation number, say, 9. After that, where q and I are the function of x only, x, q and I are the function of x, then we have to and integrating both sides, we get integration of derivative and integration are the reverse process. So we have to get that. What is the integration here? That is, derivative and integration is cancelled with each other. Y e raised to I is equals to integration of q e raised to I plus constant of integration is arbitrary constant is we have to consider first of all c, then we have consider say c1, and this is we have to consider equation number say 10. This is equation number say 10. After that, c1 is an arbitrary constant. This equation also written as, therefore y is equals to we have to write here e multiply divide, that is e raised to minus I into q raised to integration of, you have to write that q raised to e raised to minus I into integration of q raised to e raised to I plus c1 into e raised to minus I. This is equation number say we have to consider say 10. This can be written as say one of the form. This is the best beautiful solution we have to consider here. This is the final solution we have to reach. After that, we have to substitute the value of say I. What is the value of I? We have to write the equation here. Y is equals to, what is the value of I? I is, we have to substitute in equation number say 6 here. This is exponential of integration of say, we have to write that here, integration of minus p of x minus into integration of p of x into dx, this bracket. After that, integration of q into exponential of and direct we have to write here. This is one of the term. Again, integration of, we have to say e raised to minus px into dx. Then we have to write the exponential of ext of p ची व्हॅल्यू टाकतो, that is integration of px into dx bracket close into qx, this q into say px plus third term c1 into exponential of, what is the value, that is minus integration of p of x into dx, and this is say equation 11, and this is general solution of equation 2. See, what is now? See here, very importantly, we have to consider here the solution of first order differential equation. We have to consider here. First of all, we have to know what is the general equation of the general linear differential equation for the first order. That is f0 of x into d raised to n y upon dx raised to n, f1 of x into d raised to n minus 1 y upon dx raised to n minus 1 plus dot fn minus 1 of x into dy by dx plus fn of x into y is equals to say f of x. हे इक्वेशन तुमच्या लक्षात राहणं गरजेचं आहे. This is the first step. After that, substitute p n is equals to 1. n is equals to 1 टाकलं तर finally we have to get that f0 of x. Here we have to get what? That is 1. 1 म्हणजे dy by dx plus all the terms are vanished and the last term is get what? That is f1 of x into y is equals to f of x. Or this can be replaced. f0 या इक्वेशनला जर आपण f0x ने डिवाइड केलं तर dy by dx as it is. f1 of x upon f0 of x is nothing but the p of x into y, and f of x divided by f0 of x is nothing but q of x. This is equation number 2. To solve this equation, this is a linear differential equation. This can be solved by using a homogeneous method. That is, solve this equation, we have to consider q of x is equals to 0. And when q of x is equals to 0, this equation simply becomes dy by dx p of x into y is equals to 0. Now this is plus here, it becomes minus. Rearrange the equation, y is multiplied here, divide 1 upon y dy by dx is equals to minus p of x. This is equation number say 3. And finally 1 upon y into dy is equals to minus p of x into say dx. Now integrating this equation, separate the variable and simply integrate. सर्वात पहिल्यांदा तुम्हाला माहित असलं पाहिजे, हे जर इक्वेशन लक्षात राहत नसेल तर सुरुवात या इक्वेशन पासून सर्वांनी करावी. लिनियर डिफरन्शियल इक्वेशन हे तुमच्या लक्षात असणं गरजेचं आहे. dy by dx plus p of x into y is equals to q of x. dy by dx plus p of x into y is equals to q of x is the equation 2. And to solve this equation, we have to consider q of x is equals to 0. If the right hand side of the equation becomes 0, then this equation is called as homogeneous equation. Otherwise it is called as non-homogeneous. Now, when right hand side of this equation is 0, dy by dx plus p of x into y is equals to 0. And it gets that dy by dx is equals to minus p of x into y. After that, we have to 1 upon y dy by dx is equals to minus p of x. This is equation number say 3. Separate the variables and integrating this equation. Integrating 1 upon y into dy is equals to minus integration of p of x into dx plus c, where c is the arbitrary constant. When we have to consider c is the arbitrary constant, what we have to get that ln of y is equals to integration of minus p of x into dx plus c, where c is called as a constant, arbitrary constant of the integration. I think we have to understand what is the basic formula. That is integration of 1 upon x into dx is equals to log x. This is we have to remember. 1 upon x into dx is equals to log x. Means this integration is ln of x as it is integration of p of x into dx plus c is added. This is equation 4. The key exponential both sides, that is logarithm is becomes expanding to the exponential, that is y is equals to exponential of minus p of x into dx e raised to c. Understand? Because what we have to take here, exponential. Logarithm जाणार आहे, मग इथे येईल y, इथं e raised to होईल आणि इथं प्लस साइन निघून जाऊन काय होईल त्या ठिकाणी प्रोडक्ट होईल, that is e raised to c येईल. आणि e raised to c म्हणजेच सबस्टिट्यूट करायचं a is again we have to substitution for that. E raised to c is nothing but a, because of simplifying this equation into the solution, that is y is equals to a into exponential of this part as it is. This is equation number say 5. Simplify this equation, put this factor, that is integration of p of x into dx is nothing but I, and this is equation number say 6. After that we have to consider y is equals to a into e raised to, what we have to substitute, p of x into dx is nothing but I, that is minus sign is there, and that is a into e raised to minus I. Again we have to find a is equals to, this is multiply here, it becomes divide y upon e raised to minus I, and again we have to take, this is denominator minus, it becomes plus at the numerator, a is equals to y into e raised to plus I. Differentiating this equation with respect to x, what we have to get that is differentiation this equation with respect to x on the RHS means right hand side, what we have to get that d by dx y into e raised to I is equals to first function derivative of first that is dy by dx, it is nothing but y dash into dy by dx is nothing but y dash into e raised to I. Derivative of first, second function as it is, plus first function as it is, derivative of second, e raised to x derivative तुम्हाला माहित आहे. What is derivative of d by dx of e raised to 2x? That is equals to e raised to 2x into derivative of 2x is what? 2. Like that we have to write that here derivative of e raised to I is nothing but what we have to say that e raised to I, and derivative of I is nothing but di by dx, and we have to from equation 6 number is this equation we have. This is take the integration, differentiation of this equation. What we have to get that from equation 6 we have di by dx is nothing but p of x, di by dx that is nothing but p of x. Substitute this value d by dx left hand side as it is, y dash e raised to I plus y e raised to I, and this di by dx is nothing but the p. This di by dx is nothing but p, and then we have left hand side as it is, y, this common factor is what? E raised to I, y dash plus y into p into e raised to I, equation number say 7. This is y dash plus y into p e raised to I, equation number 7. Now returning, what is the concentration we have? This is the concentration of this equation. What we have to say that dy by dx plus p of x into y is equals to q of x. This equation solution we have to find. Returning to the equation 2, multiplied by e raised to I, and this can be written as what? This factor is nothing but we have to write that y dash and multiplied by e raised to I. Again we have e raised to I into y dash plus p as it is into y as it is into multiply the factor e raised to I, and here also e raised to I. इक्वेशन 2 ला दोन्ही बाजूला e raised to I ने मल्टिप्लाय केलेला आहे. अंडरस्टँड व्हॉट इट दिसतंय सर्वांना? ओके. आफ्टर दॅट y dash plus p into y, this e raised to I is the common factor into q into e raised to I is equation number say 8. Now from equation 7, this is equation 7 we have, and finally we have to write that is this factor is nothing but what? This factor is nothing but d by dx y into e raised to I, and that is equals to q into e raised to I. So equation number 9. Now where q and I both are the function of x, so integrating this, what you have to get that differentiation and integration are cancel with each other. It gets that y into e raised to I is equals to integration of q into e raised to I plus constant of integration is considered as say c1, and finally we have to write that this e raised to I is multiply here, it gets divide denominator, and here power is what? Minus I. Y is equals to e raised to minus I integration of q into e raised to I plus c1 into e raised to I. Put the value of I ची व्हॅल्यू टाका. I ची व्हॅल्यू काय तुमच्याकडे? I is nothing but equation number 6 we have, that is p of x into dx. Substitute the value of I. E is nothing but exponential of I ची value minus p of x into dx. Again we have to say substitute the value of e exponential is as it is. Integration of this is what we have, value of I is integration of p of x into dx into q of x as it is into say dx. This is what we have, dx factor, and after that c1 into e raised to minus here dx is now we are writing here dx as it is into c1 into e raised to minus I. Substitute all the value, and this is called as general solution of the equation. Finally, this equation contains a two term. One term is considered as what we have to say that first term c1 into e raised to exponential of p of x into dx. And this term is called as, the last one we have to consider here, one more chalk we have to consider, full chalk we have to need, other color. This we have to consider this term. The last term is called as a CF. CF is must be complementary function. This is called as what? CF. And first term is called as what? We have this term, first term, that is called as what? Particular integration. And finally, general solution. General solution is equals to CF, PI is nothing but particular integration plus CF. CF is a complementary function, and this equation consists of the two parts of the solution. One is called as CF and another is called as say PI. CF and PI, or generally we have to consider CF is a complementary function and PI is called as particular integration. CF plus PI. This equation, this is CF and first part is considered as say PI. General solution consists of a complementary function and the particular integration. I hope this equation is very important for the examination. Many times question is asked on that for 10 mark. प्रश्नपत्रिकेमध्ये जेव्हा आपण पेपर सेट करतो तेव्हा 3 पेपर क्वेश्चन आपण काढत असतो पेपर, त्यामध्ये एका क्वेश्चन पेपरमध्ये आपल्याला जनरल सोल्युशन ऑफ द फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन किंवा सेकंड ऑर्डर डिफरन्शियल इक्वेशन याच्यावरती क्वेश्चन असतोच, म्हणून हा क्वेश्चन सर्वांनी करूनच ठेवायचा आहे. फर्स्ट ऑफ ऑल यू हॅव टू राईट द general equation for the nth order, then we have to remember the first order dy by dx plus p of x into y is equals to q of x, and after that we have to consider the right hand side is 0, homogeneous equation, solve this equation, separate the variable, integrate it, and then go on step by step, go ahead. Equation 6 is called as say I, and after that we have to get the final equation, and that equation consists of the two part of the solution. One is called as complementary part and another part considered complementary function, and another is called as particular integration. Write down all these things and practice it more and more. Revise many times. Thank you.